If you're listening to these podcasts, you're probably young. Maybe there are some older people listening, I'm not sure. But one way to be optimistic is to say, how have human beings dealt with big problems before? Is there anything to be optimistic about? So then you can say, well, if it's not the first time that we are facing a big challenge, then we can be optimistic that we can find a way to deal with it, just like we did in the past with all our innovation, our technologies, and our understanding, our empathy, sympathy, and consideration for the poor people, and so on and so forth. So let's read this section of the politics of climate change. Yes, it is, and yo, no, it's not, and so on. So it's not the first time as well in terms of challenges. That's what some of my best friends say, people who are actually pretty smart, because the hole in the ozone layer is almost closed now, and you never hear about the acid rain these days. If you don't know what the ozone hole is, you can follow up, but quickly, as we said before, in the upper atmosphere, way above the so-called troposphere. If you know what that is, good. Otherwise, do not worry about it. There is a part of the atmosphere called the stratosphere, and the sun's energy coming in is in all kinds of microwaves, gamma rays, radio waves, and of course the light that we see. And there is some very strong, dangerous ultraviolet radiation coming in as well. But this ultraviolet radiation is absorbed by the ozone in the stratosphere way up there. Don't worry about it if you don't know. But if that ozone is not intact, if it has a hole, then the UV that needs to be absorbed by the ozone is gonna get in to the surface, and it's dangerous. It can cause cancer and cause damage to the DNA and so on and so forth. So this ozone hole was discovered way back when, and Paul Crutzen was one of the guys that won the Nobel Prize for discovering the chemistry of how the ozone hole is forming. And he was born in 1933. When the book was written, he was still alive, but he passed away recently. Okay, so acid rain is, again, remember what acid is? We talked about acidification of the oceans, because CO2 dissolves into the ocean and creates carbonic acid. There are other similar compounds in the atmosphere coming from burning coal and so on, called sulfates, and they can produce sulfuric acid. And when it rains and there is acid in the rain, lots of bad things happen. So maybe you haven't even heard about those problems because you're too young, and people are already dealing with the hole in the what, you may be asking. But go ask your parents when they were younger. Those were the environmental problems that worried us almost as much as climate change does now, and those problems have almost been solved since then. Well, not quite, but we have made lots of progress, and it shows us that we can work together. So why shouldn't the same happen with climate change, you ask? Take the acid rain in the 1980s. When your parents themselves may be very young or not born yet, photographs of bare forests and dead fish were suddenly popping up everywhere, just like we have polar bear pictures showing up everywhere now. Even the faces of the statues seem to be slowly disappearing because of the acid rain. This happens because of sulfur dioxide, ammonia, and other substances dissolved in the clouds and combined with the water to form sulfuric acid and nitric acid, and that was what was raining down upon our forests, statues, and lakes. As with climate change, those substances were released into the air because of factories, cars, cows, and so on. But there were some differences from the climate problem. Acid rain didn't travel all over the world. It fell locally, but fell mainly in areas with lots of industries. The problem was also more visible. Everyone could see that the trees were becoming bare by the acid burning and the fish were floating to the surface dead. So nearly everyone was convinced that something had to be done. When you see it, it doesn't take much effort to convince people that this is not good. Filters and other solutions were soon introduced to combat acid rain. It won't be so easy with climate change, though. For one thing, CO2 and methane pass through I'm having a little trouble reading today, children. Let's start again. For one thing, CO2 and methane pass straight through particle filters, and also because it's a problem for the whole world. As you said, CO2 released in one place quickly mixes and gets around the whole world. Has there ever been a problem that all of the world's countries have tackled successively together? Yes, and that's a sign of optimism, saying maybe we can work together and solve big problems. Yes, really, we can do it. Take a look at the hole in the ozone layer, or what's left of it, because it became big and it's slowly been closing. The ozone layer is a thin layer of the atmosphere that happens sometimes, children. The computer crashes in the middle of the recording and it allows me to restart, but now I am not sure if I'm restarting from where it crashed or I'm starting from scratch. So this will be something I'll have to look carefully again, or I may have to redo it. Well, it's okay. So we can really solve big problems, and we have the example of the ozone hole. Take a look at the ozone hole, a hole in the ozone layer, or what's left of it, because our actions to cure it, to close the hole, have been working. The ozone layer is a thin layer of the atmosphere that protects us from the sun's UV rays. In the 1970s, that layer turned out to be getting very thin about around the southern part of the earth, above the southern part of the earth, around the North Pole. The result: in southern Chile and Australia, people had a much higher chance of skin cancer, and we don't even know what happened to all the whales and other things in the ocean that went there, and so on. But UV rays are also dangerous for life in the sea, so it's a good thing that the Dutch chemist Paul Crutzen realized who the culprits were: the chlorofluorocarbons. Now you can see why they use so many abbreviations. The chlorofluorocarbons are just called CFCs. In chemistry, they are known as CFCs. That's all you need to know, except that they used to be in refrigerators and spray cans. Every aerosol can that you used had CFCs because it was very useful in that way. Once they're high in the atmosphere, the C comes away from the F, and the other C's, the chlorine, that merrily starts breaking up the ozone layer, and that was not good at all. The hole in the ozone layer became bigger and bigger, but the politicians didn't do anything because it wasn't entirely certain that CFCs were the culprits. Besides, the manufacturers of CFCs weren't at all happy about the idea of their products being banned. Profit motives can work in very dangerous ways, so they kept shouting everywhere that there was nothing wrong. They called Crutzen's theory a myth, a piffle, balderdash, complete nonsense. But other people were very worried. The hole could clearly be seen in the satellite photographs. No denying that, because evidence was there. Even though it wasn't entirely certain that it would work, it still seemed like a good idea to stop using CFCs. Imagine you're on a big ship and you're in a real hurry. In this distance, you can see something that looks like an iceberg, but it could be a fog bank, which ship could easily sail through. If you want to go around it, you will need to turn now, because a giant ship needs time to turn directions. What do? Do you gamble on it being a fog bank when you don't know for sure? Of course not. It can be dangerous if you miscalculate it, even if you're not 100% sure, 100% certain that a disaster is going to happen. You will still do everything you can to prevent and avoid the potential disaster, because if you wait until it's a certainty, then you might be too late and you may be completely wrong. This makes so much sense that it's even in all kind this makes so much sense that it's even in all kinds of laws and treaties that we need to avoid CFCs, because it could be the cause of the ozone hole that was growing and growing and was becoming more and more dangerous. And so the American government eventually did ban CFCs even before Crutzen was proved right. In 1987, countries rushed to make agreements about CFCs. In the future, refrigerators, air conditioning and spray cans would have to do without the CFCs. The CFC manufacturers were of course not happy. That change cost them billions of dollars, but later it turned out that they were actually much better off and were earning even more than before by switching to something else. And more important, the hole in the ozone layer is slowly closing up. So my friends, one problem is not the same as another, but when they need to, earth dwellers, us folks, can sometimes come together to solve their problem in a surprisingly dynamic way. So here is the earth, here is the atmosphere, and there is the ozone that's protecting us. And if you make a hole in it, then the UV rays, which are dangerous, can come through, and that could be bad news for all. Okay, so what do we worry about now? Well, that inventors of the world now say, don't you worry, it's all going to be okay. So we'll come back and see that, but first I have to make sure that my podcast is actually continuing the previous podcast and not just overwriting it, in which case I have to redo it, children. But this happens sometime, so I will do another take if there is any issue. If not, we'll come back and talk about inventions on how we are trying to solve the climate change problem. There is a difference between the ozone hole and climate change problem, because ozone hole problem had one chemical to deal with, that was CFCs, and the impact of the ozone hole was bad for everybody, including marine species. But climate change, as we see it, is impacting lots of people, but some people in Siberia may be thinking it's okay if it gets warm and melts all this snow and I will grow wheat. Or there may be other people thinking they will make money from climate change somehow. So they're not exactly the same, but it shows still that we can come together as a species and face big challenges and try to solve them together. As we discussed, the Paris Agreement is an attempt to do that. And then the question is, are we moving fast enough? Fast enough for what? Fast enough to make the planet safe for you, because you are the kids. The future is yours and you are the future. So you need to get involved also as soon as possible by learning about everything, and then maybe you yourself will become an innovator. That'll be exciting, but some of you may be following other innovators and think it's going to be okay, and you may be worrying about flying to moon and Mars. So have optimistic, fun imagination for the future, and don't be anxious about climate change. You can do something about it. Okay, so we'll come back and continue, children.